In this video, we're going to look at Unity Game Simulation. This is a fascinating tool that lets you quickly and easily test your game with a variety of parameters. You can create a simulation to test your game 1,000 times and they will all run in the cloud in parallel. So this helps you save a massive amount of time and money. Let's begin! This video is sponsored by Unity. Alright, so let's take a look at Unity Game Simulation. Unity Game Simulation provides a scalable way to increase the accuracy and efficiency of your QA and game balancing testing efforts by simulating millions of game playthroughs and interactions in the cloud. This is a feature that has the potential to be life-changing for many small and large studios. Game balancing and testing is either very time-consuming or very expensive or really both. Normally, when testing your game, you need to actually play the game. So for example, let's say you're testing a new weapon and you want to find out what is the best parameter for the damage amount. So you set a value, then you go play through a level, let's say it takes you 10 minutes, you get to the end and then analyze if you need to increase or decrease the damage amount. So you change it and once again play through the same level and once again analyze the results. So right away you can see how much time this whole process takes. The other approach is hiring some playtesters. Doing that, they can all play at once, which saves you some time, but naturally that costs you money. Unity Game Simulation solves that problem by running multiple builds running at the same time in the cloud using lots of parameter combinations. So you input testing parameters, upload the build, and wait for the cloud instances to finish all the tests and then analyze the results. Now, as you look at this overview, you might be asking the question, okay, so does that mean you need to make the game play itself? And the answer is yes, the game does need to play itself automatically since it's running on the cloud. Now, in order to do that, you have essentially three options. The first option is just a fixed series of commands. So for example, if you were testing a tower defense game, you would say at this number of seconds you place the tower on this position, then after 30 seconds you place on another position, and so on. So that's one approach. However, this option really only works for games that have a relatively fixed design without much randomness. So tower defense, idle games, possibly even some management games, and so on. If your game is more dynamic, then you have the second option, which is to make some classic AI. So for example, on a top-down shooter, you would write a classic AI for the player just like you did for the enemies. So keep trying to reach the goal and look for any nearby enemies and kill them. This is the standard AI that every game has to make, except in this case you apply it to the player. And lastly, the third option is the more complex but also more versatile, which is to use machine learning. Machine learning is a whole nother entire topic and something very interesting and very powerful, so let me know in the comments if you'd like to see a video on using machine learning in Unity. Essentially the way it works is you give it some parameters and it learns how to play the game. Now, depending on your dataset and how much time you give it to learn, it can be much smarter and faster to create than classic AI. Again, Unity already has machine learning called ML agents, so let me know if you'd like to see a video on that. Alright, so that's the overview of how Unity Game Simulation works. You make your game, then you define some parameters you want to test, you make a bot to play your game using any of the three methods, then you upload the build to the cloud and define the parameter combinations you want to test, you'll let the cloud run the build insanely fast with tons of instances running in parallel, and then when it's done, you analyze the results and apply them to improve your game. There's links in the description in order to learn more about Unity Game Simulation. Alright, so now let's see how to actually use it in the simplest test possible. Okay, so in order to get started, first you need the Unity version. As of right now, this is fully working with the 2019.4 LTS version, so use that one. So down here, I already have 2019.4 installed. And also the instances on the cloud are running on Linux, so when you install the Unity version, you also need to add the Linux build module. So here I already have 2019.4 with Linux installed. Alright, so we just want to create a new project with this. So over here, create a new project. And here I just want the most basic thing possible, so let's just go with an empty 3D project. Let's call this Unity Game Simulation. Alright, so here we are in an empty project. Now, in order to install a Unity Game Simulation, if you're watching this in the future, then chances are you can open up the package manager. And then here on the Unity registry, go down and look for the Game Simulation package. However, as of the time of this recording, it does not show up here yet. So we need to manually add the package, which is very simple. Just close the project, go into the project folder where we created the project. And here go inside packages, and you see the manifest.json file. So edit this with any text editor. So here I have it open in Notepad. So just go all the way down here and we're going to add a new line. And it's going to be this one. Here, just be careful with the commas. So on this line, you add a comma, then you add a line, and on this one, no comma. All right, so this will add the game simulation package to our project. Now again, like I said, if you're watching this a long time in the future, then chances are it has already been added to the package manager. And also, if you're watching this just a little bit in the future, make sure you check the link in the description just in case this version has changed. Okay, so with this, let's close and save this file and open the project again. And now it should automatically download and install the package. And you can verify that it installed correctly. If you go up here on the file bar, go into Window, and you see the Game Simulation button. So there it is, it's correctly installed. Now click on it. And now here we see the Game Simulation window. And right away you should see this message. So this is telling us that we need to create a Cloud Project ID in order to be able to use Game Simulation. So let's dock this window down here. And let's go up here into Window. Then go into General and open up the Services tab. Yep, that one. And now here just select your Unity ID and hit on Create. Alright, so that's it, very simple. Now we have a Cloud Project ID. And down here on the Game Simulation we do see the correct window. So what we have here is a simple interface to define all of our parameters and then to upload our build to the cloud. So without touching anything, if we just try running our game and we open up the console, yep, right away we see some messages in the console, so everything is working. Alright, now like I said, let's make the most basic example possible. So let's just move a cube towards the target area and then our parameter will be the move speed. So on our hierarchy, let's just create a 3D object, make it a cube. Alright, here we have our basic cube. Then let's make another one next to it. This will be our target. So just make a simple material. Alright, so we have our basic cube and then we have our cube target. And on the collider, let's make it a trigger. And essentially we're just going to have the cube move towards the target. And when it enters the target trigger, then we have our win. Now in order to make the trigger event work on our cube, let's just add a rigid body component. And let's disable gravity and make it kinematic. So let's make a simple script. This will be our player cube. So just attach our script onto our cube just like that. Alright, so now here let's make a simple update. And on update we're going to move transform.position plus equals. Let's move it to the right, so new vector 3, 1, 0. Okay, we're moving to the right. Let's do it by a certain move speed. So let's define up here a float for the move speed. And let's default it to a certain amount. Alright, so by move speed and also by time.delta time. Alright, so we're moving it just like this. And our testing results will be based on the total time. So let's also store that, just a private float for the total time. And on update, we simply increase it by time.delta time. Alright, so we have this. And now with this right away, we only have a single parameter. However, the big benefit of game simulation is when combining multiple parameters. So let's just add another simple parameter. Let's make it a private float for the wait timer. So essentially it will wait for this amount of time before starting to move. So if the wait timer is above 0, then we count down, and when it's under 0, then we actually move our object. So very simple. Then we have our win condition. So let's make a on trigger enter. So when that happens, then we have won the game. So here let's just do a debug.log. Say win, and then our total time. Alright, so that's it. This is our very basic test. Let's see. Here we are, and after 1 second, the cube starts moving, moves forward, and yep, enters the collider, and we have our win message. Alright, so far so good. So here we have our very simple scene. Now what we want to test is define a parameter for the move speed, another one for the wait timer, and then we check the total time for each move speed and wait timer parameter combination. So for that, let's go into the game simulation window, over here on the parameter setup. Let's click down here to add another parameter. So here we have a name. So for the name, it will be our move speed. For the type, this will be a float. And now here we have the default value. So let's put the same thing that we use. So let's put in a 5. Now in here, it is very important that the default value is a valid value. The game needs to be able to work using this value. When the cloud build is validating, it will be using this one in order to make sure it works. So for example, in this scenario, we want to test to make sure that the move speed is valid so that it reaches the goal. So for example, if I were to leave this at 0, then it would never reach the goal and the build won't validate. So make sure this is a valid value. So we have this one, and let's make another one for the wait timer. And again, it is also a float, and let's default it to 1. And after you set all the values, don't forget to click on save. This is now uploading all the parameters onto the Cloud Project ID. Alright, so here we have our parameters. Now let's actually use them. So back in the code here, first thing we need is to use the simulation namespace. So we add using unity.simulation.games. Then let's make a private void start. And on start, the first thing we do is fetch the configuration for this game simulation. So we go into the game sim manager, we access the static instance, and then we call the function fetch config. So like the name implies, this will fetch the configuration with all the parameters. So this one takes an action, which is a delegate that gets run when the download is complete. Now, if you're not familiar with delegates, go check the video link in the description where I cover them in detail. So it's an action that has a parameter of game sim config response. So let's make it in here. Alright, we have this function and this will be our delegate. Alright, so we access the game sim manager instance. We tell it to start downloading and fetch the configuration. And when that's done, it's going to call this function. So it's called in here. And then in here, we can access this object. So the game sim config response. And here we have a whole bunch of functions to get all of our various parameters. Now in our case, we define two floats. So we just call get float. And then we pass in the name for the key. So first of all, we have the move speed. And we set our move speed to this one. And then the same thing for the wait timer. And we set it to this one. Alright, so that's pretty much it for setting the parameters. Now, one thing is we only want the game to start playing after the download has finished and after we apply our parameters. So let's make a simple boolean to define if the game is ready to play. So up here, just a simple private bool is ready, and let's default it to false. And then on update, if we're not ready, if not is ready, then we simply return so we don't do anything. And then in here, after we finish the configuration, we set is ready to true, and that's pretty much it. So we start off, it is not ready, so it's not going to run anything. It's going to first wait for the configuration to finish downloading. When that is done, we assign all of the various parameters, we set it to true, and we start actually playing our game. Okay, so we have downloaded our parameters, and now down here we have our win function. So it's in here that we set the result of our testing, which in this case we want to save our total time. So in the game simulation API, the output results are called counters. So again, we go into the game sim manager to access the static instance. And then we can write counters to see all the various functions. So we have one where we can increment one every time. Then we have an ability to reset a specific counter. We can set a counter to a specific value, or we can also take a snapshot of the current state of all the counters. So this one saves the current state of all the counters at this point in time. So in this case, we just want the most basic thing, which is setting a specific counter to a specific value. So we just call this. Then for the counter name in here, let's say our total time. And we pass in the total time. Now here, one very important thing is the type of the second parameter. As you can see, this one is long and it only supports long. Now, if you're not familiar with long, it's essentially the same thing as an int, meaning that it stores whole numbers. The difference is it has a much wider range since ints are stored in 32 bits, whereas a long is stored in 64 bits. But like I said, only whole numbers, so we cannot use a float in here. So one approach would be just to cast this into a long. So this works, however, what this does is it floors the value. So for example, if our time is 1.9, we end up storing just 1. Now, depending on what you're trying to test, this can be just fine. So for example, if you're testing the time to complete the level that is usually about 10 minutes, then a precision of 1 second is probably enough. However, in our example, this scenario will run for less than 10 seconds, so a bit more precision would be helpful. So the easy solution is just to multiply it by a certain value, like let's say by 1000. So in this case, our time will be stored in milliseconds. Alright, so that's it. We are saving our counter. Now the last thing that we need is to make sure that the game quits. So to do that, we just do application.quit. This will stop the game, which will free up resources in the cloud in order to allow another instance to run in its place. However, while we're testing this in the editor, we really don't want it to quit itself. So we can add a simple compiler if. So if we are running in the editor, so we can use unity_editor. So if so, then we go into the Unity editor namespace in order to access the editor application and simply set is playing into false. So this will automatically stop the editor. And if we are not running this in the editor, then we simply call quit. Alright, so that's it. And with this, we have everything set up. So the first thing we do is we fetch the config. Then we grab all of our parameters and we start our game. And when we have our win condition, then we set the counter to save our actual value. And then finally, we quit the game. Okay, so everything is set up. Let's go back into the editor. And in here, before we upload anything, let's first try playing the game. Okay, here we are with the game running. And down here, you can see what it's doing. And now it's moving and it quits. And yep, there you go. Perfect. So here you can see everything that happened. So it started fetching the app config, then it grabbed it, and you can see that it grabbed the default value. So wait timer of 1, move speed of 5. Then it ran the game, ran the simulation. We got to the end, we wrote the counters files, and we quit the application. All right, so everything is working. Now just go into the game simulation window. And in here, let's go into build upload. And here, this will create and upload a Linux build for our simulation. So make sure you tick whatever scenes you have. Here, I just have this one. And also, let's make sure we save it just in case there are any changes. And then just give it a build name. So here, let's just make it test Unity game simulation. And that's it. And let's just do build and upload. So like the name implies, it is now making the Linux build and then it uploads it to the server. Alright, it's done. The build has been uploaded. You can see over here on the console, there you go, build succeeded and it correctly uploaded. Now when that is done, you can go here and click on the Create Simulation button. So this will open up the browser to the game simulation dashboard, or alternatively, you can go there manually. So just go directly onto gamesimulation.unity3d.com. And here you see all the various project lists. So in our case, we have the Unity game simulation. So here we are, and this is a list of all of our simulations for this project. Alright, so now we click on Create Simulation, which will take us to the same place as clicking on that button in the editor. And over here, we can start off by giving it a name. So let's give it something like the first test. Then we select our build from the drop-down menu. Right now we just have one, so select this one. And then down here we have the really interesting part, which are the various parameters. So you can see that we have the move speed and the wait timer, both of our floats. And then in here we have the crucial part of this whole system, which are the values for these parameters. So in here we can input all of the multiple values that we want to test. So for example, we want to test with a move speed of 5. Let's also test with a move speed of 3.5. And let's also test with a move speed of 6. And then on the wait timer, let's test with a wait timer of 1 and a wait timer of 0. So each of these will be different distinct values that the simulation will run with. And then down here we can see the number of parameter combinations. So we have 3 possible values in here and 2 in here, so we have a total of 6 possible combinations. So for example, the first one will be with move speed of 5 and with a wait timer of 1. The next one will be with a move speed of 5, wait timer of 0, and so on. Then this setting is the number of runs per each parameter combination. So let's set it, for example, at 5. So this will run 5 instances with a move speed of 5 and a wait timer of 1. Then it will run another 5 instances with a move speed of 5 and a wait timer of 0, and so on. So using that, then we have our total number of runs. And then down here we have the max runtime per run in minutes. So after this amount of time, the build automatically terminates, whether it is finished or not. Now in this case, we're testing a very simple example that will take something like 10 seconds per run. So let's put it just a simple minute. Alright, so that's it. These are all the settings. Now just click on Run to queue up the simulation. And yep, there it is. Over here we have our simulation. Alright, now all that's left to do is really just wait. Now naturally, this will depend on the complexity of the simulation. So in this case, it should take probably about 30 minutes. So I'm going to wait a bit and get back to it. Alright, so here I am a bit later and the simulation has completed. So in here we can see our status and it is indeed complete. And we can see how many minutes in total the whole simulation took. And then we can download the reports. So over here we have 3 types. We have raw data, aggregate data, and player logs. Now the raw data contains all the data separated for every single run. The aggregate data groups the multiple runs we saw before. And the player logs let you access the logs for each individual instance. Now these are all standard TSV files. So just text separated by tabs. You can open them in just about any spreadsheet program, like for example Google Sheets. So here I imported all those files into a simple Google Sheets. So here I have all those files nicely imported. And first of all, we've got the player logs. So this one contains a link, and with this link you can download the log for each specific run. So for example, run over here number 7, and here it is, and you can see it's a standard Unity log. So for example, if something goes wrong and a bug happens in your build, you can go through the logs to see exactly what happened. Then you have the raw data. So these are the raw results for every single run. So for example, we can see all the parameters used. So on this run right here with an ID of 22, it ran the simulation with a wait timer of 0 and a move speed of 3.5 and with a total time of 2500. So again, the counter is always long, so remember that we multiplied by 1000. So essentially with this move speed and wait timer of 0, it took 2.5 seconds. Now you can see how some parameters are duplicated, so multiple with wait timer 0 and move speed of 3.5. That is because we set it to run 5 times on every parameter combo. So we have a single line for every single one of our runs, and then we have the aggregate results. And now this one, it aggregates the results of each specific parameter combination. So over here we have all of our various combinations, and then our aggregate data. So you can see the average, the maximum, the minimum, the standard deviation, and the sum, and how many instances ran with this parameters. Now in our example, we didn't have any randomness, so the only difference here is just based on the time.delta time. So the differences here is pretty much just random noise, but in a more concrete example, this would give you some very useful data. And again, with all of this, then you can make your conclusions and figure out what to do about it. Now in our simplified example, the results are pretty obvious. So this one is already sorted by the average amount. So we can see in our obvious example, the fastest way is the highest move speed with the lowest wait timer. So wait timer 0, move speed of 6, takes just 1.5 seconds. And obviously the slowest will be the one with the highest wait timer and the lowest move speed. However, let's say that we didn't want just exactly the fastest time, but instead we wanted to end it at, let's say, 1.8 seconds. If so, then we would know, okay, so these are some good parameters for that. So with this, you can see just how versatile this system is. You can imagine a more complex example where you would use this to figure out, let's say, the best acceleration and top speed in order to have the player finish the race in 60 seconds. Or perhaps you would have an endless horde mode where you wanted the player to live on average for 3 minutes, and you would use this system to define how many enemies to spawn per wave, or countless other examples depending on exactly what type of game you're making. So this is a really awesome feature that has endless use cases and can really help you save a massive amount of both time and money. Alright, so I hope you liked this introduction into Unity game simulation. The package is in preview and in active development, so Unity is looking for all the feedback they can get. Try it out for yourself, and if you have any issues, go into the forums or email the team directly. This is a really fascinating feature that can be a huge help to both small indie developers as well as large studios. Now stay tuned for more videos on doing some interesting simulations. And also let me know in the comments if you're interested in a video on ML agents and combining game simulation with machine learning. Alright, so thanks for watching. If you found this video helpful, consider liking and subscribing, and I'll see you next time.